back, students. So here we're going to answer question 5 from the 2021 paper. Quick reminder of what problem solving is about. So it's about asking ourselves at the beginning, what is known and what is unknown? We should know both of these statements after reading the question. Before we move into answering it, we need to choose a strategy and method that you will use. You will have to apply that strategy in an organized, competent way, proficient way, without making mistakes. And to that end, to make sure you did, you confirm your solution, and confirm your solution answers the actual specific question that was asked. Because often questions are asked and they could be slight variations of the same question lead to the same strategy. So after fulfilling the strategy, it's important you go back and check that you answer the question. Okay, so let's read the question now carefully. Alice thinks that taking a shower should not use as much water as taking a bath. Great. Probably like that sentence doesn't provide any information as such, except that there's less water in a shower than taking a bath. That's what we'll be confirming. She measures the rate of flow from the shower to be 11.5 meters per minute. So we know that. So let's write that down. 11.5 liters per minute at a certain setting, and says that 9 minutes is the average time for a shower. How many liters of water on average does taking a shower use? So we've 9 minutes multiplied by 11.5, and that's based on Alice's measurement. So our strategy here is to multiply the time by the rate to find the change in volume. So the answer will be 11.5 multiplied by 9, which we'll do on the calculator. And we get 103.5 liters of water. That's a lot of water. That's an awful lot of water. A typical tank could hold 200 liters, maybe 250 liters, but that'd be a big tank, so it's an awful lot of water used in a shower. But staying in 9 minutes is also quite a lot having the shower running. But anyway, Alice then estimates that the shape of a bath to be a rectangular tank. So we know the length of the bath is 130, so we're going to start drawing a model here. And the width of the bath is 50, and the depth is 28. And they're all in centimeters, so we have to find the volume of the bath. So the strategy and the method is to go to the equation for a rectangular solid. Now we'll just quickly look at the log tables and see, do we have in area and volume something for, what am I looking at here? Length and volume, probably. Length and area, no, surface area and volume. Do we have any equation for a rectangular solid? And we don't really, except to say we have an equation for a solid of uniform cross-sectional area. And in this case, B would be the length by the breadth by the height. Okay, so in a way you could say this is, technically speaking, could be a rectangular solid. Back to the question, we're going to multiply those three numbers together and see what we get, and that will answer, and we will have the answer then in centimeters cubed, and we'll divide by 1,000 to get the litre answer. So we get 182 and 3 zeros. So that's 182 litres. Okay, so in comparison, it's slightly bigger, but not quite twice as big as a shower. Okay, now we're on to section B, which is a different question completely. So we'll stop the video there and I'll do 5B in another video. As always, students, I'll see you in the next one.